Hello, and thank you for stopping by the video. Today I'm going to talk to you about my chi-square and McNemars test calculator that I built for students within the College of Nursing and at the University of Cincinnati. And if you're not in that group, you're still welcome to use the application. So a chi-square and a McNemars test are used when comparing the frequencies of nominal or categorical outcomes from two groups. And if the nominal or categorical data that are collected from those two groups are independent, then we're going to do a chi-square test. And if the nominal or categorical data from the are collected from match pairs of variables, then we're going to do a McNemars test. And I'm going to give you an example of matched pairs here in a second, and we're going to actually do McNemars test using this calculator. So below here, I go into some detail about how you want to set up your data, but I did create a dummy file here that you can download and check out. It's called McNemars example, and it's very straightforward. It includes a pre and post scores for two questions. And so let's take a look at that. So to upload your data, all you do is just go to Browse here, and you click on your data. And if you want to download my McNemars data, you can just click this download button here, and that will download it to your desktop. But we're going to go ahead and click Browse, go to McNemars, it'll say Upload Complete, and then here on the right you actually can see the data. It's only going to show the first 3 lines from that file, but you can go through and continue to scroll through and look at the rest of the data if you'd like. You can't really change anything here, so I can't change any of these observations. If you want to do that, you need to do that in Excel. Make sure that your file is a CSV file, though. This will not read in Excel files. It only will read in CSV files. So with McNemars test, we're going to use that when we have paired data. So paired data is specifically, it's data that's basically where you've captured information on the same people over the course of time, twice potentially. So here we have a question that we're asking individuals pre-intervention and a question we're asking post-intervention. And maybe this question, the reason why this is a McNemars test and not a paired t-test is because our outcome is categorical. It's either 0 or 1. 0 indicates that they got the question wrong, and a 1 indicates that they got the question right. Okay? So what we want to do here is we want to see, are there more 1s happening post than there are pre? So basically what we're doing, again, this is when you would use a chi-square or McNemars, is if you're wanting to compare the frequency of events across two different groups. Here our groups are pre and post, and because the groups are technically the same people, pre and post, we need to make sure we're going to take that into account and do a McNemars test. So once I've uploaded my data, it's all read in correctly and I've checked that, I can just come down here and click on the type of test I want to do. You can select chi-square or McNemars. Again, if you're doing pre and post analysis, you'll want to select McNemars test. Then you can select the confidence level. This is a decimal, but technically it should be read as a percentage. So this is 95% confidence level. Then we're going to select the variables that we want to compare, or the variables from the data set that indicate the groups that we want to compare. We don't want to compare ID to ID. The ID is just indicating to us which individual we're looking at. So for instance, this row right here, we're looking at the second person in our data set and what their pre and post score was. We don't have any interest in comparing the ID variable, but what we do want to do is compare question 1 scores to question 1 post scores. So question 1 pre to question 1 post. Once I do that, in the background, it automatically runs the McNemars test. And the nice thing, from the summary output, we get to see exactly what the interpretation is of that test. So I'm going to go through that really quickly here. So from a data set with sample size 20, so again, this 20 is going to get automatically pulled in based on the data set size that you imported down here. So this, if you imported a data set of size 100, it would say sample size of 100. Continuing on, I compared the frequency of Q1 pre, again, this is pulling in automatically based on what I selected over here in this tab, to the frequency of Q1 post, using a McNemars test with 95% confidence. Those are going to automatically change based on what you select here. The observed frequency difference was tested for whether the observed frequency difference would be likely due to chance. From this test, the resulting p-value was 0.013 and indicates that because the p-value is less than 0.05, we reject the null hypothesis and conclude that there is statistical evidence to support the hypothesis that the frequencies from the two variables are different from one another. So what we're doing here, again, is we're checking to see if there are more correct answers in the post question to the pre. And we're doing a McNemars because we have paired data. Basically, both of these columns here are coming from the same individual, so we have to take that into account. The p-value is giving us an idea of whether or not the difference in frequencies that we observe from post to pre are due to chance or not. And so if that p-value is small, that means that it's unlikely that that difference that we observed was due to chance. And so that's what this statement is trying to summarize, that because the p-value is small, specifically we choose a cutoff of 0.05, that's a very common cutoff, we conclude that we have evidence that the frequencies from these two groups are different from one another. The nice thing about the app is you can copy and paste this and put it directly into a paper. I don't recommend you putting this directly in without any consultation whatsoever from anyone. I do recommend that you copy and paste this, modify it yourself, maybe reach out to me or reach out to a statistician to help you put this into some more appropriate language that has to do with what you've done. But this should get you started, and for the most part, this calculator should be able to analyze and test comparisons between lots of pre and post interventions for categorical outcomes. If you do find this useful, or you maybe have used this calculator for results that you're putting into a paper, check out the About This Application tab. You can see more information about how I built it, what it's based on, as well as how to cite this web application. And you can do that right here with this specific statement that I put down here. It's in APA format. And also, you can reach out to me at this email here. I'll be sure to put this web application in the link in a link below in the description file of this video. So again, thanks for stopping by. I hope this has been helpful to you. Let me know if there's anything I can help with. Thanks a lot.